Hello everyone, welcome to the very first lesson for the computing aspect of Project Pascal. My name is Terence and I'll be one of your 3 mentors for this program. For the very first lesson, we will be going through some introduction to programming as a whole, such as the various programming languages and the importance of them in our digital world and the 4th Industrial Revolution. Afterwards, our 2 other mentors will take you through a very basic introduction to Python, such as the various data types and the variables. So without further ado, let's hit into it. So first up, I'll be introducing the 3 mentors for our program. So firstly, my name is Terence Lin. My CCA is softball and I like sleeping and gaming. And a fun fact is that I got beat by leeches in Malaysia when hiking. Your 2 other fantastic mentors are Sashil and Kush. I'll let them introduce themselves when we have an actual face-to-face lesson. So this is just some details about the overall lesson structures. For the 1 hour and 30-minute lesson, the first 15 minutes will be spent on recapping on last week's content and making sure that you guys truly understood everything that we taught. And then for the next hour, it will be a lecture style. And for the last 15 minutes, you guys will be attempting your own problems that we will assign to you. This will be the overall lesson overviews for the entire program. We're starting off with very basic stuff like introduction, data types, and some operations I can do in Python before we head into the more interesting and complicated stuff like machine learning and databases. As for some very basic lesson etiquette, all of you have heard of this like a million times in your school, but if you have questions to ask, just unmute yourself and ask, but make sure to not interrupt your mentors in the middle of their sentence. And also, very common stuff, just try to be attentive and respectful during a lesson. Moving on to the lesson proper, this will be today's agenda. I'll be taking you through the introduction to programming, and Sashil and Kush will be taking you through the basic Python lessons. So first up, we'll be going through the historical context. Now this might sound a bit boring to a lot of you, but I think it's quite important to know this before we delve into programming itself. So maybe you guys have learned in history, but humanity has gone through multiple industrial revolutions, with each phase giving us increased production and efficiency. So firstly, there came the first industrial revolution back in the 18th and 19th century, where the steam engine and mechanical production was invented. Think of stuff like trains and like sewing machines, which helped to replace human labor and then increase our efficiency by a lot. And then in the 19th to 20th century, there came the mass production in the second industrial revolution, where the division of labor was found out to be a lot more efficient. So for example, think of like a product. Back in the past, like expert craftsmen would spend a lot of time and effort to make this one product. But after the industrial revolution, people found out that if you had many different workers working on only one specific area of the product, it can be created much faster and much more efficiently. And then the third industrial revolution, which a lot of us are familiar with since that's when we grew up. This was when robots were invented, where you can see like robots creating cars in factories. And then come to where we are now, the fourth industrial revolution, way beyond what robotics could achieve, which is the integration of the cyber and the internet into physical systems. I'll be explaining this more in the next slide. These are some of the few aspects of the fourth industrial revolution, with many cool things like 3D printing, which is additive manufacturing, autonomous robots, and AR. How this is different from the third industrial revolution is that it uses both the digital and the physical world, whereas in the third industrial revolution, people are just coding robots that perform set out tasks for them. So to quote the World Economic Forum, the fourth industrial revolution represents a fundamental change in the way we live, work, and relate to one another. It is able to combine and merge the physical, digital, and biological world in ways that creates both huge promise and potential peril. So what our Pascal programming project aims to do is to introduce you to some of these aspects and prepare you for the future. Now that we have learned the historical context, we'll be moving on to what is coding specifically.
God fucking.
Okay, well, that video was an exaggeration. It is actually very true that most of the time we will be relying on other people's work to do our own. So here are some resources that you guys should be using in the following program if you guys don't understand any of the things that we're saying. Stuff such as documentations and websites and bootcamps or YouTube videos will be very helpful for your learning journey. Now I'll be going through a overview of the different programming languages that exist. Many languages have been developed for many different reasons because each of them have their own unique specializations and pros and cons. And these here on the slides are just a few of the very popular options that exist right now. For example, we have C++, which is very fast and lightweight and used to run programs that require a very speedy return. And then for another example, HTML is used for the front-end website and app development. This is what you see when you inspect Google and Chrome pages. And then we also have JavaScript, which is used for web and software development. And then finally, the one that we're learning is Python, which is quite a beginner-friendly option and it's very flexible and has uses in many different areas. And just be aware that this list is very non-exhaustive and there are a lot of different other programming languages. So now I'll be turning the time over to Sashil to guide you guys through the very first lesson for Python.
Hi everyone, my name is Sashil and I'm one of the mentors for today's program. So I'll be taking over the part of introduction to programming before Kush goes into some more interesting things about programming and so on. So for this section, we will be talking about basic Python, right? So things like why are we actually learning Python, why is Python so important in today's world, and so on. So actually, Python is mostly used for web development, things like software development and doing simple mathematics and accessing databases. So it's very good for these kind of things. And the websites you're seeing every day is actually a lot of the logical process behind it is done by Python, which is a programming language. So uh, when you want to access databases, if you want to sort of modify files, edit files, your simple Excel files and so on. Python is actually a great tool for these. And one of the reasons I like Python is because the readability of Python is really good because like it's simple English, right? So anyone, even a simple like anyone who understands English can more or less know what's happening um, when they are reading through your Python script and so on. So let's watch a nice YouTube video on what exactly what Python is and some interesting facts. Let me stop sharing my screen. Okay, let's watch the video here. Okay.
In this video, I'm going to answer top 3 questions my students ask me about Python. What is Python? What you can do with it? And why is it so popular? In other words, what does it do that other programming languages don't? Python is the world's fastest growing and most popular programming language, not just amongst software engineers, but also amongst mathematicians, data analysts, scientists, accountants, network engineers, and even kids, because it's a very beginner-friendly programming language. So people from different disciplines use Python for a variety of different tasks, such as data analysis and visualization, artificial intelligence and machine learning, automation. In fact, it's one of the big uses of Python amongst people who are not software developers. If you constantly have to do boring, repetitive tasks, such as copying files and folders around, renaming them, uploading them to a server, you can easily write a Python script to automate all that and save you time. And that's just one example. If you continuously have to work with Excel spreadsheets, PDFs, CSV files, download websites, and parse them, you can automate all that stuff with Python. So you don't have to be a software developer to use Python. You could be an accountant, a mathematician, or a scientist and use Python to make your life easier. You can also use Python to build web, mobile, and desktop applications, as well as software testing or even hacking. So Python is a multi-purpose language. Now, if you have some programming experience, you may say, but Mosh, we can do all this stuff with other programming languages. So what's the big deal about Python? Here are a few reasons. With Python, you can solve complex problems in less time with fewer lines of code. Here's an example. Let's say we want to extract the first 3 letters of the text hello world. This is the code we have to write in C#. This is how we do it in JavaScript. And here's how we do it in Python. See how short and clean the language is? And that's just the beginning. Python makes a lot of trivial things really easy with a simple yet powerful syntax. Here are a few other reasons why Python is so popular. It's a high-level language, so you don't have to worry about complex tasks such as memory management like you do in C++. It's cross-platform, which means you can build and run Python applications on Windows, Mac, and Linux. It has a huge community, so whenever you get stuck, there's someone out there to help. It has a large ecosystem of libraries, frameworks, and tools, which means whatever you want to do, it is likely that someone else has done it before, because Python has been around for over 20 years. So in a nutshell, Python is a multi-purpose language with a simple, clean, and beginner-friendly syntax. All of that means Python is awesome. Technically, everything you do with Python you can do with other programming languages, but Python's simplicity and elegance has made it grow way more than other programming languages. That's why it's the #1 language employers are looking for. So whether you're a programmer or an absolute beginner, learning Python opens up lots of job opportunities. In fact, the average Python developer earns a whopping $116,000 a year. If you found this video helpful, please support my hard work by liking it and sharing it with others. Also, be sure to subscribe to my channel because I have.
Okay, so that video was a great introduction to Python, and I think the job opportunities is quite convincing and attractive, definitely. So I think one aspect he said was that Python is a very beginner-friendly language, and that's why we are starting off with Python. And even though it's beginner-friendly, a lot of difficult, complex tasks can be solved quite simply with Python. And I think the syntax and the indentations and stuff, which we will talk about later or in upcoming lessons, is also what makes it so easy to read and understand, right? Because in languages like C++ and so on, the lines will be written on the same line, but for Python, you actually have to indent and move on to the next line and so on. So now let's go on to some basic Python knowledge, which is very important to code some simple websites and so on. So moving on. So let's talk about variables, right? So variables are firstly how you identify a certain element. So let's say I assign a variable to something. So let's say I have the number 10. So as you can see, my first variable is sum of scores. So I want to give the number 10. So the sum of scores can be 10. So all I have to write is sum of scores equals 10. So I'm assigning the variable sum of scores to 10. So in my upcoming lines of code, I can simply refer to 10 as sum of scores. So over here is some simple syntax which you have to keep in mind when you write Python. And but luckily, actually, when you are actually doing code and when you're doing coding, these kind of errors will be sort of popped up so that you don't have to worry too much. You don't have to exactly memorize all these. When the error pops up as you're coding, you can easily rectify it. And I think one worry some of you might have is that are you going to code in this program? And we definitely have to, because practice is important when you're coding. But since some of us might not actually have access to like Python, to download Python and so on, we're actually planning to share some Google Colab notebooks. So what Google Colab does is that you can access this link and code on it. It's like a simple Google folder, Google Drive folder, so it's accessible to everyone and it's easier to use. So here are just some like reminders. So it's case sensitive, so capital B, a small b, and all these are different variables, right? So and also do not use spaces, punctuation, and so on. Just keep it simple. And also don't use Python keywords, which we'll go on to in the next slide. And how do we comment? So on Python, so what are comments exactly? Comments are basically to improve your readability. So let's say I add this code, sum of scores equals 10. Then you want to tell the person reading your code that I have assigned this value to sum of scores because so on. So it's just like typing normal English, just that it's after a dash. Okay, sorry, a hyphen. Okay, now As you can see, there's a hashtag sign at the top. Now moving on, these are some variables which have already been pre-assigned by Python in the language. So things like false, none, true, and these have already been given a value. These are already known variables, so you can't actually assign them like and equals 10 is something we won't do because and is already something defined and it's literally and. I said this and this, right? So just combining both these things. So we usually don't include both these. We usually don't assign these variables which are already included in Python as variables. Moving on, these are some data types, which is basically what we refer to some of the things in Python. So you can see 1, 2, 3, 4 are integers, or just int in Python, very simple. And when you add a dot, as we know in math, we call it a float. So the same thing in Python is called a float. And string, so this might be a bit new, but also very simple. String is basically when you have normal basic text, right? So how you identify strings is when there's a quotation mark, can be single or double, around the string. So let's say ABC123 quotation mark on each side, that means it is a string. And finally, a bool. It's quite interesting what a bool is. So bool is basically this value of true or false. So let's say 2017 is greater than 2018. I type that in, and since 2017 is less than 2018, I'll get false, right? Because my statement there is not true, so it's false. So there's some interesting facts on the left here which says that the most positive version is 1.79 times 10 to the power of 308. So after that, you'll just have to use infinity or negative infinity. Moving on, we have some mathematical operators, some simple ones, same as the ones we use in everyday mathematics, plus, minus, multiplication, division. These are the signs we use. So on the right-hand side here, you can see some simple examples. Over here, so but these are a bit large numbers, so we can use simple things like 5 plus 6, you get 11, and so on. So and as you can see here, there's a 0.0, right? So these numbers actually float. They are not integers because there's a point. Okay? So very simple stuff. And floor division might be a bit new to some of you. So it basically returns the value on the left divided by the right, rounded down to the nearest integer. So it does not give you the remainder, but it's just rounded down to the nearest integer, right? And the note here also states that it may not necessarily be an int. As you can see, since there's a dot, a floating point, as they call it, it's a float. And when you say something to the power of something, so 2 to the power of 5, I just give 2 star signs, which means it's exponentially multiplied to the number, right? So then we have modulus, which is just what is the remainder of what you get, right? So floor division gives you the value, while modulus gives you the remainder, right? These are all mathematical things we learned in basic mathematics. Now, when we want to compare two items, right? So over here, bool is where it comes in here, it comes into play. So we say 2017 equals, so it's comparing these two values, right? 2017 equals 2017. Obviously, that's true. It's the same thing. But 2017 equals 2018 is false, right? So this statement there, where saying 2017 equals 2018 can be basically read as, is 2017 the same as 2018? Is it equivalent to 2018? And you get false. So false is a bool value, or bool is short for Boolean, right? And same thing below, exclamation mark and a equal sign gives you non-equivalence, right? So 2017, you can read this as does not equal to 2017, and that's false because it is equivalent, and so on. So still very simple, basic Python stuff. You can try this on your own, some simple math. You can type in any numbers, use Python as your calculator even, right? So these are just some more comparing stuff, which makes life a bit more easier, when you want to say, is this greater than this, and so on, then you can simply ask 2017 less than 2017, false, right? And so on. You have all these examples here. I'll let you go through it for a while, but just have to take note that less than or equal to or greater than or equal to, the arrow symbol is before the equal sign, right? So it's less than or equal to, and below we have greater than or equal to. And then you get a value if it's false or true, depending on what you give. Now, finally, as we come to the more important part of Python, which you'll see everywhere, is a function. So a function is basically what you call when you want something to be done. So let's say I want to add 5 times 5, but I don't want to keep saying 5 times 5, 5 times 5. So I can put it under a function. So I can name this function. So you say, oh yeah, you have function name. So I can say multiplication function, right? And you have arguments. So arguments are what you will add into the thing. So let's say under function, I say x times y. So I want this function to return x times y. And later on, maybe I'm calculating calculating something, and I wanna know what 5 times 10 is. So all I have to do is call this function. So I'll say multiplication, and bracket my x, right, which is defined initially, now becomes 5, and my argument 2 becomes 10, right? So all I have to do is call that. So multiplication 5, 10, and bracket, and then I'll get the answer 50, because initially when I defined this function, I said x times y, return x times y. So you'll see an example here for a clearer example on the right. So define DEF add numbers. So you have to add DEF in front of a function so that the system knows that it's a function. So A and B, and then so what this function does is it returns A plus B. So later on, when I'm calling this function, all I have to do is add underscore numbers, bracket 5 and 10. Now I'll get 15, right? Now I can call this function again somewhere else. I can put add numbers 7, and then I'll 7, comma 20. Then I'll get 27. So it's very simple. It basically returns me what this function needs to do. And initially, since I don't know what numbers I have, I don't know if it's 5, 20, whatever it is, I can just say A or B, right? Because later on, I can just insert whatever value I need. So it's very useful with these kind of functions, because I can define any function and later on just call it whenever I need. Let's say I'm creating a web application, and let's say when my user clicks on this button, I want the function to be like this. I just add this function there, right? And I can so it's very simple to just call it, and makes the code more easier to read. And I'm calling these functions at all these places I need it. And I don't need to keep writing this whole return A and B, return A and B, A plus B, return A plus B, but I just call the function, and that's it, right? So these are some common functions we have inbuilt into Python. So print length stands for length. So length of, let's say length of this string. So length of a string gives me how many characters there are in that string. So let's say I put len bracket quotation marks string quotation mark, and then bracket again, then I'll get string. So I'll get 6 as my length of that, right? So there's some built-in functions which are already have been predefined into Python, similar to how there are some variables which are predefined into Python, right? So now next up, Kush will be going through some interesting things about Python. Yeah, thank you.
Hi, I'm Kush, and today I'm going to be teaching you guys about binary, denary, and hexadecimal. These are important concepts in the world of computing. But before we build up to that, let's start by understanding a bit. A bit is just a digit, which can either be a 0 or a 1. By the way, have you ever wondered what the byte in gigabyte stands for? Well, a byte is just 8 digits, put together as you can see here. Traditionally, when writing our bits, we like to group them in batches of 4, as you can see on screen. This is done to make reading the number less troublesome. Now, to link this concept of bits to binary, let's convert denary, or numbers that you and I use, to binary. Lucky for us, this process is actually quite simple. All you have to do is take it a step at a time. Divide your number by 2 and write down both the quotient and the remainder, as seen here. As you can see, 117 divided by 2 is 58 with a remainder of 1. Great. Now let's keep doing this with our quotient until we're left with 0. From here, we read our remainders from the bottom to the top, giving us 111, 01, 01. Additionally, the bit at the very bottom is considered the most significant, since it carries the greatest numerical weight. Now, this process might seem great, but there's a problem. That felt quite repetitive, right? Especially as the numbers get bigger and bigger, we'll just have to keep doing the same process over and over again. Who wants to do that? So let's create a program to convert a large number like 21 from denary to binary. So to do this, please take this time to head over to the Google Colab notebooks to try this problem out for yourself. Congratulations, guys. You've now graduated from binary. Let's dive headfirst into hexadecimal and how it works. Binary only allowed one digit to take up two potential values, either a 0 or a 1. That's why it was considered base 2. 2 for the number of possibilities each digit could have. Since hexadecimal is base 16, can anybody guess how many potential values each digit has? Correct! The answer was 16 potential values per digit. Since from 10 onwards, numbers start taking up multiple digits, hexadecimal uses the letters A to F to fill in the remaining 6 possibilities after 9. This might sound confusing, but I promise it's easier to understand with an example. Alright, to help us better understand, let's convert 37 to hexadecimal. Similar to what we did with binary, we keep dividing it and writing down the quotient and remainder, but this time by 16 instead of 2. 37 divided by 16 is 2, remainder 5. 2 divided by 16 is 0, remainder 2. Now that we've reached 0 as a quotient, we're done. Just like before, we read the remainder from the bottom up. Thus, 37 in hex would be 2, 5. As you could imagine, this would also get tedious as the number gets bigger and bigger. Now let's try and create a program to convert a larger number like 3,499 from denary into hex. Let's now hop on Colab to figure out this one out. Great progress, guys. I hope you're excited because now it's time for the final challenge. Let's try and convert this number from binary to hex. Good luck, programmers.